All right, so let's talk about lexical this. Yesterday, if you remember, we talked about what lexical this is. Can anyone tell me what lexical this is? An object. Okay. What else?
A keyword.
A keyword. 4 letters. THIS, right? What else?
It refers to the object that is calling the function.
Fantastic. Yeah, that's it. That's it. Save got the job, right? All right. So in this particular example that we covered yesterday, Boris Merkel, what is that going to print? Boris Merkel. Let's have a look. Fantastic. Yeah, this is what we learned yesterday. Now I'm going to introduce a subtle change, very subtle, and we'll see how catastrophic the impact of that subtle change is. Look at line number 5. Yeah, that's a classic function. What's the alternative to classic functions, guys? Arrow functions. Let's transform that into an arrow function. What will that function return now?
Something catastrophic.
Something catastrophic.
Because you said.
Let's run it. Oh, undefined. It's like, what the hell? So far, we've been believing that classic functions were equivalent to arrow functions. But probably by the first time ever, we can see a scenario where the behavior changes. In other words, we cannot change from one to other without side effects. That's scary. Yeah? Why? Because arrow functions change the behavior of lexical this. And actually that's the only difference between classic functions and arrow functions. They are equivalent unless you want to deal with lexical this. Why? With a classic function, lexical this refers to the object that called the function. But with arrow functions, now it doesn't care. JavaScript doesn't care who invoked the function. User 1 or user 2, it doesn't care. Yeah? If it doesn't care, how is lexical this value calculated? It's inherited from the parent context. And that's a bit mind-blowing. Let me show you an example. Something we learned yesterday. Back to what we learned yesterday, nothing new. Do you remember yesterday we did window.firstname equals Angela, window.lastname equals Johnson, and then we did window.getFullName equals user1.getFullName, and finally we did window.getFullName. What will that return? Correct, Angela. Yeah? Why? Because it's still using a classic function. Lexical this referred to the object that called the function. So lexical this equals window. Yeah? That's why even if we remove window keyword, will it work? Same thing, right? Remember, window can be implicit. Yeah? That's what we learned yesterday. But now, look, back to the original example of today, of arrow functions. User1, get full name, arrow functions. Anyone has any idea about what will this algorithm return? Before it was undefined. Will it be still the case?
It will take the window object.
Yes, correct. Look at the outcome. Boom. Angela Johnson. Where is that coming from? Lexical this, because we are using an arrow function, looks for the parent context, the parent object. Is there any parent context? No, not really. There is nothing about that. If there is nothing about your current context, it defaults to the global. Yeah, the global is window. Yeah, I think it's also worth to mention that I'm all the time talking about window, but window only applies in front-end JavaScript. Yeah, in the browser. If you are working with Node.js, there is no window. Does anyone know what's the equivalent of window in Node.js? Global, which is pretty much the same thing. Yeah? But technically speaking, in Node, you don't do that. That doesn't work. In Node, you do that. Why? Because window, it's supposed to be the actual window, the screen. That works in a web browser because you have a screen, you have a user interface. But Node runs on the backend. There is no window, something dark, something hidden, right? That's why window doesn't really make sense from a semantics point of view. Anyway, that returns Angela Johnson because there is no parent context. But let's introduce a parent context. Look at what I'm going to do next. Get full name. I'm going to create a new object inside of the get full name. Yeah? First name. I'll explain that in a second. Right, so can you still see the screen? Hopefully, right? So let's try to understand the algorithm. We call user1.getFullName. So we are running that function. I'll try to avoid the keyword this unless it's extremely necessary. So we run that function. And then what happened here? Return user2, which is an object here, dot get full name. In other words, we are calling that function. So can anyone figure out what will that algorithm return? Let me simplify it a bit. First of all, classic functions, only classic functions, yeah? Classic function here, classic function there. What will that algorithm return? Boris, Donald, or Angela?
Donald.
Why Donald, Sonia?
Because it's nested inside user1, so when you get the full name, you actually get Donald.
What do you think? Do you agree or do you disagree with Sonia?
I think it's Donald as well.
Anyone else? Does anyone disagree with Ed and Sonia? I think they are. Ooh, you think it's going to be Angela? Based on what we learned yesterday, when using classic functions, lexical this refers to the object that called the function. Which object called the function? Is it window? No. Is it user1? No. Is it user3? No. Is it silicon roundabout? No. It's user2, right? Because of that, lexical this refers to that object. And consequently, this first name is the same as user2 first name. Yeah? In other words, Ed and Sonia are right. Yeah? That's what we learned yesterday. But, what happened if I transform the inner classic function into an arrow function? What will that return? Boris, Donald, or Angela? Boris. Why Boris?
Because we go to the parents.
Correct. Thanks to the arrow function, now we don't really care who is invoking the method. Yeah? It will simply ignore the parent. Yeah? And what do we have on the parent? User1. Because of that, that will return Boris. Any questions?
This is something on purpose, or it's a side effect of arrow functions?
That's the goal of arrow functions. The goal of arrow functions is not only to save some keystrokes, right? Because the syntax is shorter. The goal of arrow functions is to give you the ability of keeping control of lexical this more easily without having to deal with bind, call, apply. Do you remember yesterday how we were forced to change the value of lexical this dynamically? So thanks to arrow functions, this is supposed to be easier. And the very last question, what happens if I do that? That's the most complicated scenario. What will our algorithm print?
Will that then go to the window?
Say it again, Jack?
Will that go to the window? What we had at Angela?
Look at what Jack said, right? Our Arsenal fan said that it will print Angela. Why, Jack?
Because it's doing what it was doing previously. It's parent.
Correct.
The window is the parent.
Correct. So Jack is absolutely right. First of all, let's prove that. It's true. You see, he's right. Why is that? Well, first of all, user1.getFullName. So for now, theoretically, lexical this refers to user1. So we go here. But then we said, wait, I got an arrow function. So that gets invalidated immediately. Yeah, lexical this here will never refer to user1 anymore. It will refer to the parent. Because there is no parent, there is nothing else above, parent will be window. Yeah? But then we said, okay, but wait, be careful because we are not done yet. We are going to do some stuff in here. User2.getFullName. That means that in theory now, lexical this refers to user2. But once again, we have an arrow function. That means that it doesn't matter who is invoking that method. Yeah? In other words, here it will look up for the parent lexical this because of the arrow function. It will check here. But because we also have an arrow function here, it will go one level above. And because there is nothing else above, it will check on the window object, which is Angela. This is what we got before. Yeah? What happens if we got a classic function here again? What will that display? Angela or Donald?
Will it display Angela still?
Why Angela?
Because your arrow function at the top still dictates you pull from the parent to that.
Yeah, that's okay. But we have a classic function here. So you mean that this doesn't have any impact?
I feel like the arrow function overrides it. See one above.
That's,
I think Donald John Home.
why?
Because user1, it's calling a function that calls particularly user2, and it doesn't have the arrow function there.
Yeah, that's correct. Seb is right. Look, remember, if we have a classic function, that's the scope of the object that called the function. Yeah. So in other words, in that particular case, it's not relevant what we do here, because we always get the deepest scope. Yeah. User2.getFullName, it will come here, and then we say, okay, classic function. That means lexical this refers to the object that called the function. In other words, lexical this refers to user2. Because of that, that returns Donald. Does it make sense? Yeah. As you can see, this is relatively complicated, but it's logical. So if we keep adding more examples, look, if we add user-free to make it even more complicated, eventually, this always ends up getting mind-blowing, right? But let's try to sort this out. It's quite complex, isn't it, right? First of all, before trying to understand how that works, let's add some breakpoints. Do you remember that? Can anyone tell me the execution order? Okay, so Seb goes first. Seb said 23. What else, Seb? All right, timeout. Next.
Okay.
Will it go 23,
Jack,
6,
23, 6,
10,
10.
yeah, 17,
Right.
so 20, then 17, and then we throw over the objects here.
So it's, you said 10,
20,
20,
then
right. Next.
23,
Kelly wanted to say something. Kelly, 23, 6. Yeah.
and that's good for the objects as well.
Time out. Who else? Wait. But Kiran. 23, 6. 20? 20 what else? Like Jack was so 26, 10, 20, 10, 20, 17. No, you can't. Who else? Esteban. 23, 23, wait a minute, 23, 6, 20, 10, 17. Interestingly, everyone said something different. You can still participate. Bilal, Ed, Kibon, Faraj, Sonia. Wait. Wait. Ed said 23.
Let me go with
10.
17.
17. 6. And 20. All right. As I think Sonia agrees with Esteban, right? Kibon, do you agree with any? I think we got all the combinations possible, or pretty all, most of them. Yeah, Faraj?
10. 17.
Yeah.
23.
Yeah.
20.
Hmm? 23, yeah, okay. Bilal, Kivon, Kivon.
23. And
Sorry, I need to make some space. So you said 23. What else?
20.
20,
Then 6.
6.
Then 17.
Yep,
Then 10.
yep. Okay, and
3, 6, 10, and that's it.
we got Bilal. I think it's the last one, right? Yeah, Bilal. What do you say, Bilal?
23, 6.
23. Do you agree with anyone or not?
Yeah, so just 23, 6, and 10.
At 23, Bilal. 23, 6, and 10, and that's it.
Yeah.
23, 6, and 10. That's interesting. All right. So, no, 10 and 17. Okay. 23, 6, 10, and 17. Okay. Okay. Interesting. Interesting because of multiple reasons. This is a relatively classic job interview process because here you can clearly see who has a good idea about the coding flow. Yeah? And without understanding the coding flow, it's very complicated to debug and to fix problems and stuff like that. If you want to change your solution, no. If you want to, yeah, right. But if you now, after looking at the algorithm, you want to change your mind, you are not allowed to give a new solution. But if you agree with any of your colleagues, you can say that, like, oh, I was wrong. I agree with Bilal or with Kelly or with Faraj or with. So Kelly, correct. So now Kelly joins. Yeah. Anyone else? No?
Yes, right.
You join Esteban? But you join Esteban because you are convinced or because many people is joining the group?
There's maybe one bit that I'm not 100% sure on that extent.
Right. Let's find the solution. Yes, Esteban is right. Yeah. And consequently, Sonia and Kelly are right as well. Why? So the main thing here, and this is for Faraj mainly, the starting point is here.
That's what I wanted to change.
Yeah, correct. So you mentioned that the first is line number 10, but line number 10 won't run unless that function is invoked. Yeah, so the first thing is we go here, get full name, 23. Because we run get full name, immediately next line is line number 6. Yeah, so it's 23 and then 6. But then next one cannot be 10 because to run number 10, first of all, we need to invoke that method. Yeah. So we go down, and after 6, we run 20. Yeah. And once we run 20, then we stop here. We run 10. Yeah. And then we'll run 17. I did another breakpoint here, but line 14 will be the last one. Yeah, so let me add that to the solution, 17 and 14. Let's run it to see if the theory is right. 23, right? Then it should stop on line number 6, correct? Then line number 20, correct? Then line number 10, correct? Now go to 17, right? And finally 14. Fantastic, yeah? So that's the way the flow works. But now, what's the eventual outcome of the algorithm? What's the character now? Is it Boris, Donald, Angela, Nigel?
Nigel.
Why Nigel?
Because it's a normal function.
Correct. Seb is right once again. It doesn't really care what happened above. The important thing is the deepest level. if the deepest level has a classic function, that's it. Yeah, there's a sort of a firewall, stops there. It doesn't look about. Yeah, because on line number 13 we declare the function as a classic function, lexical this will refer to the object that call the function. Here you go, Nigel. Yeah. So if we run it completely, here you go. And what happened, let me get rid of the breakpoints once we hopefully understand the logic. If now user free is an arrow function like that. What will it return now? Donald. Why Donald? Bilal?
Next one was a classic function.
Correct. Bilal is right. You see, it's pretty logical if you think about it. User free get full name, but wait, arrow function. Let's look for the parent one. Is this a classic function? Yes. Stop here. Yeah? Because of that, the value, eventual value will be the object that invoke user2.getFullName, which is here, right? Lexical this will refer to user2, and that will return Donald. Here we go. And what if we do that like that? What will it, very last question of the day, what will that return? Angela. Yeah? Why? Yes, you are right, because here we don't have any classic function. We don't have any firewall. Yeah? It will go up, above, and because nothing stops JavaScript from looking for a parent function, eventually it will stop on the root object, which is the window. Here you go. Yeah? Why is it Angela? Because user3.getFullName, it will come here, but because we have a classic, we have an arrow function, it will say, I'm going just to inherit the parent, so it will go to the parent function, which is also an arrow function, so it will go to the level above, which is also an arrow function, and then what?
This I understand, but when did we put Angela?
21 minutes ago.
He put it on memory.
We've done that before, yeah. At some point, we can do that again, guys. We can do first name equals Bilal, last name equals magic, right? So what will that display? Bilal magic.
It's in the window.
Correct. Here you go, because it's in the window. And what happened if, last question, I do delete window.firstName and delete window.lastName? Whoa.
No,
Ooh. Angela. Angela is gone. Yeah?
No.
First of all, because it got overwritten by Bilal. Yeah? But then, after that, we delete that property from the window object. Empty? Will be undefined. Yeah? Will be undefined. Let's have a look. Here you go. Undefined. Yeah? So that's pretty much it. I mean, if you understood that in combination with what we learned yesterday, that's pretty much it. I will strongly recommend you to create a snippet and play around with different combination, arrow function, classic function, bind, apply, call, blah, 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 and try to predict the result. Yeah? Don't go crazy. If I keep making that example a bit more complicated, eventually it will be mind-blowing. Yeah? But at least something like that proves that you really understand how lexical this and how inheritance works in JavaScript. Anything else? No? Cool. That was it, guys.